so welcome again, everybody. A few things real quick before we begin. I want to share some good news with you. If you've been struggling on the SAT, if you're nervous about the SAT, it's really not nearly as bad as it looks. It's not nearly as scary as it looks. And if you can learn to look at the questions the right way and simplify the questions, the whole test just opens up and becomes really, really straightforward. And if you do the right kind of prep, no question that they throw at you on the actual test is going to surprise you when you see it. You're going to know how to handle it. So don't be intimidated at all. And the way that I teach it, again, I'm all about simplifying the questions. So that's good. But also, I want to be realistic too. If you think that just taking an 8-hour class is going to get you a big score increase, you're mistaken. You're going to have to do the work. And so kind of the analogy that I use is that I'm showing you the playbook right now. Right, these are the plays that you need to use, and when it comes to game time. But you got to practice the plays on your own. Does that make sense, guys?
Yeah.
You got to practice.
Yes.
So I'll show you what to do. But as long as you kind of keep up with the work that I'm giving you between classes, and then I'm going to, at the last session, I'm going to give you my SAT Math game plan, how to approach your prep from that point. If you actually follow those steps, you're going to see a good score increase on your SAT. Okay? All right. So let's start with the rules for mathing. Okay? If you've got them in front of you, that's great. If you don't worry. You should be able to see them on the screen. Can you guys see them on the screen right here? My rules for mathing?
Yes.
You see that? Okay, great. All right, so I would love to read these together. We're just going to read the first two rules. That's what we're focusing on the first 2 days of the class. So let's start with Alexis.
Yes.
All right. Can you please read for me? Read rule number 1. This is the one that you said made you happy, I believe. Loud and proud, please.
Yes. Avoiding algebra whenever possible. Instead, plug in values for the variables and solve.
Yeah, this is rule number 1 because this is by far the most useful strategy I could teach you for the SAT, by far. And I would say, like, plugging in values in place of the variables works for about a third of the problems on the SAT, and maybe more. Now, there's different ways of, what variables do you decide to plug in? There's sort of a, there's a way to do it, and there's a little bit of an art to picking the right kind of variables and approaching it. I'm going to show you how to do that. But if you can, in general, take problems with variables and turn it into arithmetic by plugging in actual numbers, then it's going to be really easy if you can do arithmetic. So that's rule number 1. Rule number 2, Alexis, why don't you go ahead and read rule number 2 for me, please?
Eliminate incorrect answer choices using basic logic. For word problems, remember that you are dealing with real-world problems and real-world situations.
Yeah, great. Thank you so much. Yeah, so if you're reading a word problem and you look at an answer choice and you're like, boy, that number seems way too big. Like, it doesn't even seem realistic. Like, I was working on a practice test the other day that one of the answer choices suggested that you needed like 2 pounds of chocolate for each cupcake that you're making. If that sounds like a crazy value to you, it's crazy. You don't even have to worry about it. It's not, it's these are real world solutions to real world problems. So if it doesn't sound realistic, it's not. You can eliminate it using basic logic. Does that make sense?
Mm-hmm.
So there are actually some word problems where you don't even need to calculate the right answer. Just by using logic, you can eliminate all the incorrect answer choices and get the right answer without a calculation. We'll get to all that. Okay, so those are the 2 rules we're gonna focus on for the first 2 days. Later, we'll get to the geometry problems, and I've got some strategies for that too. But for right now, it's avoiding algebra and using basic logic. Okay, so without further ado, let's jump into some of these questions. And I've got a question already up on the whiteboard, and I kind of want to work. We're going to work on these together. Be aware that if you see the whiteboard right now. Yeah, there's an undo button. There you go. Yes, it's working. You can't write on the, because I'm screencasting my whiteboard. You can't write on that. If you want to write on the whiteboard, you actually have to go to the tab where the whiteboard is open and write on it. But I think it's pretty intuitive. You'll be able to figure it out. So I'm just going to go down the line here, and we're going to start with Blaze. Blaze, go ahead and read rule number 1 for me, please.
I'm sorry, rule number 1.
Oh, I'm sorry. Question number 1. I apologize.
If x minus 1 divided by 3 equals k, and k equals 3, what is the value of x?
Okay. Have you seen this question before, Blaze?
No, but
No?
I've seen questions like it.
Okay. Now, there's a way to solve this with algebra. Okay. Do you think it'd be pretty comfortable solving this by like, isolating that x variable? Do you think you could do that? Maybe.
I don't think so.
Yeah, that's okay. You don't have to do it here. Let's go. I've got good news. You don't need to do that. That's what I'm getting. So let's use the strategy of plugging in values in place of the variables and solving. Let's do that. Okay. So what are we going to plug in place of the variables here?
3.
Yeah, we got to plug in that 3 for k, right? Does that make sense? And then look at the answer choices, A, B, C, and D, right? Blaze, those are all possible values for x, right?
Mm-hmm.
So let's just plug in those values for x, those values in place of x, and see if we get a true statement. Does that make some sense?
Mm-hmm. Yeah.
So we'll plug in a 2 for x and a 3 for k, and if we get a true statement, we know that's the right answer choice. Does that make sense?
Yeah. Mm-hmm.
Let's do it. All right, can you do that on the whiteboard for me, buddy?
Okay, so 2 equals 1, then 1 divided by 3 is 3.
All right, is 1 divided by 3 3?
No.
No.
Oh, wait. Sorry.
No, it's not, right? So, so do we have to worry about answer choice A?
No.
Nah, it's gone, right? That doesn't work. 2 doesn't work, very simply. All right, so let's try plugging in 4 for x.
So,
You're doing great, by the way.
4 minus 1 is 3. 3 divided by... sorry, I've run out of room.
You're good.
3 divided...
You can use sort of pinch with 2 fingers and kind of scroll around if you're on a tablet.
Not.
Oh no, you can press the minus button there's a zoom in, zoom out in the upper right hand corner of the whiteboard. Or there's that hand button you can also scroll around with. Like so.
3 divided by 3 is 1.
Okay. Does 1 equal 3?
No.
No, it does not. So we don't have to worry about answer choice B either. Is this making sense, guys, what he's doing here, or no?
Yeah.
Yeah? Okay. Here's how I would plug these in. And yeah, we can eliminate B. Let me show you how I'd plug in answer choice C 9. I would just kind of plug it right into the equation as it is, right? So where there was an x, now there's a 9. So I do like 9 minus 1 over 3. You guys see that on the whiteboard? 9 minus 1 over 3 equals, and then we're plugging in at 3 for k, equals 3. And I'm just going to see if that's a true statement. What's 9 minus 1?
8.
8. And is 8 over 3, does that equal 3?
No.
No, very simply, it just doesn't. All right, so C is gone. It's got to be answer choice D, process of elimination, right? Because A, B, and C didn't work. And it is, okay? But now here's the deal. We can confirm this, okay? And I want to use this strategy in general for all these problems that we're working on. I recommend doing it on the actual SAT as well. You want to not only eliminate all the incorrect answer choices, you want to be able to confirm the correct answer choice. And if you can do both, you can feel pretty confident in your answer, right? So let's plug in that 10. And let me see plug in that 10, Blaze, kind of like I did for the last one.
So 10 minus 1 over 3 equals 3.
Okay. All right. And what's 10 minus 1?
That's 9.
9? Does 9 divided by 3? Is 3, right? So true statement?
Yes.
All right. D is confirmed. It is answer choice D. Any questions about that, guys?
I don't think so.
No? Do you guys want to go over how to solve that algebraically? Do you even want to go over it? I mean, we can. I like to, I do like to show my students kind of how to approach it, just to let you know, if you've got options. There's always more than one way to solve a problem. Let me show you real quick what it would look like. So we've got x minus 1 over 3 equals k, and I'm just going to plug in that 3 for k. We want to get x alone, so we're going to multiply both sides by 3. Those 3's cancel out. We get x minus 1 equals 9. And then you get x alone, we got to add 1 to both sides, plus 1, x equals 10. We can do that, but honestly, I still think the easiest way is just to plug in the values. And there's no operation to mess up, which is why I still recommend that first method. Does that make sense?
Yes.
Okay.
I did notice one way you could do the problem.
Yeah.
What you could do is you could plug in 3 for k, and then you can do the reverse operations, what they want you to do to x. You can multiply 3 by 3 and then add 1 to it.
Yeah. That's that's what we did here, roughly, right? Mm-hmm. More or less, yeah. And look, when it comes down to it, like, I'm down with whatever works. If you're really, really comfortable with the algebra, go and do the algebra. You can, but I still recommend, even students that are pretty good at algebra, I see them make a lot of silly mistakes with the algebra, and you're guaranteed to get it with the arithmetic if you can add and subtract and divide and multiply, and most students can, so I recommend it. All right, I'm going to clear the whiteboard and put the next question up. All right. This is all from SAT practice test number 1. All right, these are pretty easy questions here, but we're going to practice this strategy. Go ahead and read for me. Oh, here we go. Mr. O'Grady, welcome. Can you hear me? All right. Was that was Blaze? Did you solve that last one, right? Jonathan, yes. Can you hear me?
Yeah.
Why don't you go ahead and read question number 3 for me, please?
Okay. On a Saturday afternoon, Armand sent M text messages each hour for 5 hours, and Tyrone sent P text messages each hour for 4 hours. Which of the following represents the total number of messages sent by Armand and Tyrone on Saturday afternoon?
Okay. A couple ways to do this again. We can solve this kind of algebraically. Let's practice the strategy, right, of plugging in values in place of the variables. So go ahead, Jonathan. Give me a value for M text messages.
2.
2. I love it. Okay, so we're going to set these values. So M equals 2. Okay, so which means Armand sent 2 text messages each hour for 4 hours, and then Tyrone sent P text messages. Give me a value for P.
3.
3. I love it so much. Right. You don't want to pick like 0 and 0, by the way, not here, because if you did, you get like, I think every answer choice when you plug those values back in would give you a 0. So, I think these values are absolutely perfect. All right, now the question is, which of the following represents the total number of messages sent by those guys on Saturday afternoon? So if Armand sent M text messages each hour for 5 hours, how many messages total did he send? Just Armand.
10.
10. And then if Tyrone sent 3 text messages each hour for 4 hours, how many did he send?
15.
Not 15.
Oh, wait, 4 hours. 3.
Yeah.
12.
12, yeah, 12 text messages, right? And the question is, how many did they send in total? So we'll just add those 2 together, and we get
22.
2. Okay? All right, good. So if M is 2 and P is 3, then these guys sent 22 text messages. All we got to do now is take those values, plug them back into the answer choices, okay? And the correct answer choice should give us 22. Mm-hmm. Okay, so let's look at answer choice A and test it. Does that give us 22?
No.
I don't know what it is, but I know it ain't 22.
Yeah.
Right? I mean, it's 9 times 2, so that's 18. 18 times 3, whatever that is 54. I guess 54 or whatever. But I mean, it's too big. It's not 22, right? Does that make sense?
Mm-hmm.
A is gone. What about B? Is that 22?
Definitely.
Definitely not. If A is too big, B is way too big. We don't even have to calculate it. I'm not gonna, okay? And this is where, again, really these 2 strategies of plugging in values in place of the variables, they really work in combination together. Right? That one and using the basic logic, right? Because once you start plugging in the values and you're dealing with real numbers, the illogical answer choices just jump out at you, Okay, so use both in tandem, plug-in values and basic logic. What about answer choice C?
Yeah.
Does that work?
Yes.
Let's do it together here. And I'll do this on the whiteboard. So we got 5 times m. We said m is 2 plus 4, and again we're plugging in 3 in place of p. 4 times 3, and that gives us 10 plus 12, which is what?
22.
It is 22. So that looks good. Okay, I don't want to eliminate it. Let's try answer choice D. We'll do the same thing. 4 times 2 plus 5 times 3. What does that give us?
That gives us 19. No.
4 times 2 is 8.
8.
5 times 3 is what?
15.
15. What's 8 plus 15?
23.
23. Not 22.
Yeah.
Not D. We can confirm C. Questions about that one?
No.
No? Make sense?
Mm-hmm.
Now, again, like, some of you are really good with algebra. You could look at it and be like, well, I think it just looks like it probably is C. Some students can do it that way, and that's great if you can do it, but you're guaranteed to get it using this method, and especially once the questions start getting a little more complicated. Notice this is the third question on section 3 of the test. It's the third math question you're seeing. They ramp up the level of difficulty. This strategy really shines on the more complicated questions. So I still recommend doing it. Even if you think you know the algebra here, you're guaranteed to get it if you can do arithmetic. Does that make sense, guys?
Mm-hmm.
Okay. All right. Let's go to Mr. O'Grady. I know your name is not Natalie. Can you hear me, buddy? I know you. I think you can hear me. I can't hear you yet. All right. Try to get your mic set up. You might be on mute. All right. So we'll go back to Alexis then for the next question.
Okay.
All right. Can you hear me, Alexis?
Yes.
Great. I'll clear this one. Move this one up. And question number 4. Yes, love this one. All right, Alexis. Loud and proud. Go ahead and read question number 4 for me, please.
Kathy is a repair technician for a phone company. Each week, she receives a batch of phones that needs repairs. The number of phones that she has left to fix at the end of each day can be estimated with the equation P equals 108 minus 23D, where P is the number of phones left and D is the number of days she has worked that week. What is the meaning of the value 108 in this equation?
Yeah, so there was a lot of information here. Sometimes I like to underline the last sentence of the question, which I'm going to do right here, because that's always what you're solving for, is going to be in the last sentence of the question. So I recommend underlining that and focusing on that. What is the meaning of the value 108 in this equation? Okay. Let's start approaching this one using that basic logic strategy, okay? I want you to read, Alexis. Let's look at some of these answer choices, and I think we should be able to eliminate one, maybe 2 of these that just those numbers just don't sound right. Like, that doesn't seem realistic in a real world situation.
C.
Yeah, C sounds pretty crazy. Go to read C for us.
Kathy repairs phones at a rate of 108 per hour.
108 phones per hour. Stop and think about that for a moment, guys. Right? Like, yes, the appropriate reaction to that is to laugh. That is an insane rate of repair. 108 phones per hour. Because you're repairing, like, almost 2 phones per minute. At that, right? So, like, she would have to be, like, some, like, crazy cyborg repair person. That's just an insane... Can we agree that's an insane value?
Mm-hmm.
Yeah, that's nuts. So right off the bat, just logically, I want to eliminate C. Any others that you want, that we think we can reasonably eliminate? And maybe not.
Well, maybe B, because it says, right, the number of phones she has left to fix at the end of each day can be estimated with the equation. Well, no,
Don't worry about the algebra right now. Like, I didn't even want you to think about math. I just want you to think about logic. Like, does that sound like a reasonable number? Don't try to do the algebra here. You know what I'm saying? What do you guys think about D? repairing phones at 108 phones per day. What do you think about that?
That does sound a little unrealistic.
Sounds a little unrealistic. I might eliminate it, right? I mean, even if she's fixed, so she's working 8 hours a day, then we're still talking that's I don't know, 12 phones an hour, something like that, which would be like a phone every, 5 minutes. That sounds really fast. Repairing phones. I could be wrong. Let's hold off that one. But at the very least, we can eliminate C. C is just crazy. Okay, does that make sense? But I'm very suspicious of D. Okay, let's apply the strategy of plugging in values in place of the variables. Okay, Alexis. Here's what I want to do. I want to plug in some values for D into this equation they give us. Right? The P equals 1 to 8 minus 23D, and I want to see how many phones she's going to have left to fix as the days move along. So let's plug in a 1 for D and find out how many phones she has left after she's worked 1 day. Does that make sense, Alexis?
Yeah.
Okay, great. So go ahead and plug that in. And I want to see this here on the whiteboard.
Okay.
Yeah, you might have to open up the tab with the whiteboard, like if you're trying to write on the tab with the screencast, you won't see anything, but there we go, I see. Okay, I got you now. So, yeah.
Hold up.
There's an undo button. Yeah, there you go. And you can also erase if you want to, but there you go, 23. And we said D is 1, so it's going to be 23 times 1, right? Okay, great. So this is the equation for after she's worked 1 day, right? These are how many phones she has left, which is P. Does that make sense, guys? What she's doing here?
Mm-hmm.
Yeah? Everybody else? Make sense, guys? Yeah?
Yeah.
Okay. All right, so what is that? What is P when she has worked 1 day? You can use a calculator if you want to here. I know it's in the non-calculator section, but we're focused on the strategy.
85.
Yeah, 85, right? So P is 85 when she's worked 1 day. Okay, let's work just a little bit to the right of where you're at right now. Let's plug in a 2 for D. I want to see what happens after she's worked 2 days. Okay, how many phones she has left to fix after 2 days?
Do you want me to do that?
Yeah, please do that.
Oh, okay.
And right now, we're not drawing any conclusions right now. We're just kind of experimenting with different values for the variables, and we're seeing how changing the values changes the other values. And we're just looking at this like an experiment. We're seeing what happens. Hudson, welcome back. Can you hear me, Hudson? Can you hear me, buddy? All right. I don't think if you can hear me, awesome. You might have to set up your mic. You might be on mute.
There we go.
Okay. All right. Welcome, Hudson.
Thank you.
All right. All right. So what is P, Alexis, when P is 62. So after she's worked 2 days, there's 62 phones left. Okay? So she's worked 1 day, 85 phones left to fix. After she's worked 2 days, 62 phones left to fix. Boy, I'll bet we got some insight now. I bet we can eliminate some of these incorrect answer choices now. Okay? Let's test answer choice A. Go ahead and read that one for me, Alexis.
Kathy will complete the repairs within 108 days.
At this rate, is it going to take her 108 days to fix the phones? What do you think, Alexis? Is it going to take her 108 days?
No.
No. I mean, look, don't get me wrong. It's a true statement. It's probably, but she's going to be done with this like in 5 days. I don't think that's the meaning of 108. Does that make sense? Right? It may be a true statement, but that's not the meaning of 108. And it's just, yeah, she's going to be done within less than 5 days, probably, at this rate. So we can eliminate A. What about answer choice B?
That's possible.
That's possible, right? She starts each week with 108 phones to fix. That might make some sense, too, right? She had 108 to start, and after she worked 1 day, there's 85 phones left. After 2 days, 62 phones left. That makes some sense, right? Let's leave it. Let's leave it for now, okay? And then go ahead and read answer choice D for me, please.
Kathy repairs phones at a rate of 108 per day.
Is she repairing phones at a rate of 108 per day?
No.
No. How many is she repairing per day?
23.
23. And that's really obvious now after plugging those values, right? So I think we can eliminate D. It looks like B. But let's confirm it. Okay, we can confirm it. I'm going to plug in a 0 for D. Okay? I'm going to plug in a 0 for D. And so P equals 108 minus 23 times 0, right? Which means she's worked 0 days so far. Does that make sense why I plugged in a 0 for D?
Yes.
We're saying this is the start of the week. She hasn't worked anything. She hasn't done any work at all. So P equals 108 minus 0, which is just 108 when she's worked 0 days, which essentially is answer choice B. Does that make sense, guys?
Yeah.
Okay. If you look at the questions, sort of like a little experiment, and you can test things, just kind of play around with values, see what happens, and generally can kind of figure out what's going on with the equation and eliminate obviously incorrect answer choices. But again, it's all about taking what is sort of abstract algebra and making it concrete with real numbers. Any questions about number 4?
Mm-mm.
We're good? All right.
Yeah.
Let's get rock and roll. I'm going to clear the whiteboard again. And all right. By the way, these are all real SAT questions. These are from actual practice tests released by the College Board, the guys that make the test. I'm very picky about the materials I use. You want to use all the College Board stuff. If you're using like a Princeton Review book or like a Barron's book, I'm very suspicious of most third-party materials. You really want to use the stuff from the guys that make the test. All right. So we're on question number 6. I would love it if Alexa just read that one. So we're back to Blaze. Blaze, go ahead and read question number 6 for us, please.
H equals 3A plus 28.6. A pediatrician uses the model above to estimate the height, h, of a boy in inches in terms of the boy's age, a, in years, between the ages of 2 and 5. Based on the model, what is the estimated increase in inches of a boy's height each year?
Okay. Blaze, what are we solving for here?
We're solving for the estimated increase of a boy's height each year.
Yes. And that's right. There's a lot going on here. This word problem. I'm going to underline what we're solving for here. The estimated increase in inches of a boy's height each year. Okay. Let's start by doing that basic logic thing, right? Rule number 2, okay? And take a look at the answer choices, Blaze. Do you have little brothers and sisters by any chance?
A little sister.
You got a little sister. Okay. I don't know if you know much about like how fast kids grow or how fast they don't grow, but take a look at some of these answer choices, and I'll bet using some basic logic you can eliminate some pretty crazy looking answer choices.
I'd say D and C.
Yeah, I feel very comfortable eliminating D as an answer choice. All right? Very comfortable. And I would say C for that matter too. But let's talk about D for just a minute. If a kid's growing 14.3 inches per year, you've got like a 2-year-old, all right? Let's say he's like 2.5 feet tall, whatever. After 3 years, that kid is going to be like, we're talking like a 5.5 foot tall 5-year-old. Right, or after 6 years at that rate, right? Like 6.5 feet tall, 7 feet tall. That's insane. Okay, that's like a parent's nightmare, actually. Yeah, that's just nuts. Does that make sense, guys? Why we can just logically eliminate D?
Mm-hmm.
Kids are gonna pick it because like they're crunching, they're putting some numbers together, and they're like they calculate something, they get a number, and then they try to match it up. And you don't have to think like that. Think in terms of just basic logic. These are real world problems with real world solutions. So 14.3 is gone. Even C is pretty silly, right? Almost 10 inches per year. Right? That's almost a foot per year. Again, we're talking like a 5 foot tall 5-year-old still, which is terrifying. Great for basketball, but just terrifying from the parents' perspective. So I don't even have to worry about C and D. Don't even have to worry about them. Does that make sense, Blaze?
Yeah.
Okay, great. Now here's the deal. Even if this is all you do, this means you got a 50-50 chance at a tough problem, and this problem isn't super easy. Okay, I'm cool with that. Those are pretty good odds. Okay, Now, we can confirm this, what the right answer choice is here. So let's use the strategy of plugging in values in place of the variables. I think we can plug in some values for A. They're going to really simplify this question and make it really clear. What values should we plug in for A, the age of the kid?
I'd say in any number in between 2 and 5.
Any number between 2 and 5. In fact, like, let's start with 2, right? And then we'll find out how tall the kid is when he's 2, right? The H value.
Mm-hmm.
And then plug in a 3, and we'll see what the increase is when he's 3, right? We can calculate. We don't have to guess about anything, right? We can find out what the increase is. All right, so let's do that. Let's find out how tall this kid is when he's 2. So let me see, plug those in. Hopefully this kid is not going to be 5 feet tall. We'll see. Okay.
So then, if we multiply the 3 and the 2, that would be H equals...
You're doing great.
6 plus 28.6.
Yeah. Do you know what that is?
That would be 34.6.
Yeah, 34.6. Great. Okay.
So his height in inches would be 34.6.
Yep. When he is 2 years old. Okay? Great. Let's see how tall he is when he is 3. And we can pretty easily calculate the increase then. So let me see you do that.
So that would be H equals 3 times 3
Looking good.
plus 28.6, which equals 9 plus 28.6.
Looking good. Which is what?
Equals 37 point.
Perfect. This is great. You're doing great, please. Okay, so what's the increase from 2 to 3?
That's 3 inches.
So 3-inch increase. If you're going to guess what the correct answer choice is, A or B, what would you say it is?
A.
It's A. It's A, right? I mean, that's a 3-inch increase. All right. Now, we could confirm it again if you really wanted to. You could plug in a 4 for A and see how tall the kid's going to be. But we know that, I mean, that's going to give us, I'll tell you right now, it's going to give you another 3-inch increase. Okay. And that's it. It is 3 inches, answer choice A. Any questions about that, guys?
No.
Does that make sense how we solve that?
Mm-hmm.
We're just turning all this into arithmetic. You know, it's not magic, nothing fancy, but these are like skills. They're like, you know, skills you had in like 7th or 8th grade, and that's all you need to solve these problems. Okay. All right. Great job. Let's do some more. I'm going to clear this. Is this different from how you guys have been approaching the SAT previously?
Yeah, kind of. No.
Some of you have been using these strategies?
Yes.
That's great. If you have them, this is going to be easy. All right, so question number 8 is up on the board, and I would love to hear from who just read. That was Blaze, right? So we're back to Jonathan. Jonathan?
Mm-hmm.
All right, go ahead and read question number 8 for me, please.
If A over B equals 2, what is the value of 4B over A?
Okay. Okay, so we're gonna use this strategy again, plugging in values in place of the variables. No algebra necessary here. Let's come up with some values for A and B that we're going to plug into this question to find the value of 4B over A. Okay, what are we going to plug in for A and B?
A2, B3.
Okay.
Wait, no, that's...
Yeah, I'm glad you caught that, right? We can't just plug in any value, right? You see that? Because we've got whatever values we pick for A and B, when we divide A by B, we've got to get 2. So give me some other values such that when we divide A by B, we get 2.
Would A2 be 1 work?
Yeah, great. Why not? A equals 2, B equals 1. Any other values that would work?
I mean, 4 and 2.
4 and 2, 8 and 4. I mean, anything such that you divide A by B, get 2 works. Great. Okay, but this is really easy. 2 and 1. Let's do it. Okay, now what do we do?
Plug it into the new one.
Yeah. Let me see you do that. Can I see you do that on the whiteboard?
Yeah.
Let's see what we get.
I'm on the... Okay, there we go. So... 4. Oh wait, no, that's 1.
Yeah, B is 1, right?
Over
Yep.
2.
Looking good, looking good.
Right.
Great.
It's kind of messy.
Yeah, no, you're good, you're good, you're good. It is legible. I don't have the prettiest handwriting either, so you're in good company. Okay, good. And so what is that? What is 4 times 1 divided by 2?
That's 2 again.
It is. Answer choice C. Done! That's it! How easy is that? How easy is that?
Extremely.
The answer is that is insanely easy. Ridiculously easy. If you use this strategy. It works, again, for probably a third of the problem, sometimes more, on the SAT. Okay, and for some of the really tricky ones too. So, this strategy, if you actually do this strategy alone should give you, a significant boost on your SAT score. If this is all you do. Different.
Mm-hmm.
This would give you a boost. Okay. And I remember the first time I saw this problem, years back when I saw this, and I didn't know what to do. I didn't know I didn't know how to solve it mathematically, algebraically. I didn't. And now, it's a third grader could do this if you plug the values. All right, I'm going to clear this, and this is all on one SAT practice test. I've just picked the first questions on this is SAT practice test number 1. We haven't even gotten through question number 10, right? So we've done 6 or 7 questions so far using this strategy, and it just works. All right, let's see who is up next. Mr. O'Grady, can you hear me?
Yes.
Yeah, great. What's your name again, buddy? I know it's not Natalie.
Owen.
Owen, that's right.
Yeah.
Okay, good. All right, just make some notes. Okay, great. Owen, go ahead and read this question for me, and we'll solve it together. Okay, buddy?
Alright, what is the solution xy to the system of equations above? 3x plus 4y equals negative 23. 2y minus x equals negative 19.
Okay, great. Okay, now, so this is clearly a system of equations problem, okay? And, we can solve this doing the algebra. We can do it, and sometimes you do need to on the SAT. There are a couple questions you might see where they don't give you the answer choices, and you just gotta, you actually have to solve it. But here, they give us the answer choices, right? They give us potential values for x and y that satisfy both equations.
Yeah.
So how do we test this by plugging in values?
Yeah.
How do we do it?
Just plug it in for one of them and see if it works, and then plug it in. If that one works, plug it in for the other one.
Yeah, these are potential x and y values, right? These are ordered pairs,
Mm-hmm.
right? So that's going to be your x value, that's going to be your y value. Just plug those into the equations and see which ones give you a true statement. And we've got the right answer, okay? So let me see you do that here on the whiteboard. Just plug them all in. Now, okay, so you're plugging to the bottom equation. Wait.
Yeah.
Hold on. Let me stop real quick. So you plugged in I think you plugged in a -5 for y.
Oh,
Right.
yeah.
So
Flip this one to...
yeah, all you just got to pay attention to the variables you're plugging in, right? So
Yeah.
yeah, there you go. Good. What is that? Is that a true statement?
Yes.
is negative 5. No, it's not a true statement. We don't need to worry about A. A's gone. Does that make sense, what he did here, guys? Or no? He just plugged in these x and y variables into the bottom equation, tested it. He got negative 4 minus negative 5, which is negative 4 plus 5, which is going to be that's going to be 1, not negative 19. So that doesn't work for the bottom equation. It's not going to work. A's gone.
I'm a little confused.
Go ahead.
How did he get the negative 4 plus 5?
Because I'll rewrite it by plugging in the values. So it's 2 times, now the y value here for answer choice A, the y value is negative 2. So it's 2 times negative 2.
Okay.
Right? Minus, and I probably would have started with the top equation, just me, but it works out nicely that you could, I think the top equation would work for A, but it doesn't work for the bottom equation. So it worked out just fine. So it would be 2 times negative 2 minus x, and x is negative 5.
Okay.
Equals negative 19. Okay? Which it just doesn't, right? That's going to be negative 4 plus 5 equals negative 19. It's not a true statement, so we can eliminate A. Does that make sense?
Yes.
Okay. I would probably be more systematic about it, like I said, and I would probably plug those values into the top equation first. But it doesn't, this worked great, and we eliminated A. Okay? So I'm going to clear some room for you here, Owen, on the whiteboard, and why don't you plug the answer choices, or the values for answer choice B into the equations. Let's start with the top equation. I think it'll be easier to follow along. So we're going to plug in a 3 for x. And a negative 8 for y. Do you see what he's doing here, guys? He's plugging in the values from answer choice B. So he's plugged in a 3 for x, negative 8 for y. Is that a true statement, Owen? Is 9 minus 32, is that 23? Yeah, that's good. But we got to plug it into the bottom equation, too.
Yeah.
Let's see if that works. So this is y. Now notice, by the way, they flipped the x and y values here. Like in the first equation, the x is first, and the second equation, the y is first. So great job not getting tricked by that. Is that a true statement? I think we found our answer. And we have. It's answer choice B. Okay. If you wanted to, you could go through C and D and plug in those values and eliminate those. If you want to. Those don't work. I mean, they're not going to give you 2 correct answer choices here in this case. It is B. Any questions about that? How many algebras did we do there, guys? The correct answer is 0 algebras. We did no algebra whatsoever. That's just arithmetic. Right? Plug in the values and place the variables. That works. Works on this one. Any questions? No? We're good?
Yeah.
All right, great. All right, let's do some more. And just to give you guys a heads up, we are going to take a little 3-minute break here in a couple minutes. If you got to run to the restroom. If you're anything like me, you drink a lot of coffee to get going. Sharon, go ahead and read question number 11 for me, Sharon. Loud and proud, please.
Okay. B equals 2 minus...
Yeah, just go and read the question. Yeah. Just read the question. Sorry.
Okay. In the equations above, B and C represents the price per pound in dollars of beef and chicken. Respectfully, X weeks after July 1st during last summer, what was the price per pound of beef when it was equal to the price per pound of chicken?
Okay, what was the price per pound of beef when it was equal to the price per pound of chicken? Yikes. Okay, let's stop and step back for just a minute, okay, and take a look at the answer choices, okay? Are we dealing with a large value for X, Sharon, or a relatively small value for X, the number of weeks?
I would say a small value.
Yeah, it's probably a relatively small value, right? It's definitely less than 10, right? It's definitely less than 10. I'm looking at the numbers now. It's probably less than 5, right? Because if the biggest value is answer choice D, 335, X can't be bigger. In fact, it can't be bigger than 4. Because of that equation right there. Right? X can't be bigger than 4. It might be smaller than 4, but it can't be bigger than 4. Does that make some sense? Or no?
How did you get 4?
Well, because it's the X weeks since July 1st, right? And when X is 4, the price of beef is $3.35. If X is anything bigger than 4, right? I'm thinking in terms of money. And maybe let's stop. Forget about math again. Like this is money, right? Of $25.25 is a quarter, right? 4 quarters is $1. So we're talking about $2.35 plus another $1, which is $3.35. Does that make sense?
Oh, okay.
Right?
Yeah.
We're just talking about money here, which is and you got to kind of make that shift again. We're talking about real world values here, not just like hypothetical, equations. Does that make sense?
Yes.
Okay, ladies, questions about that? That why we know the value for X weeks since after July 1st is relatively small because of the relatively low value of the answer choices. Does that make sense? Yes or no?
Nope.
It does not make sense.
Yes.
Who is that? Thank you so much for your honesty. I am so grateful. I appreciate it. Who is that? Elizabeth or Caroline? Elizabeth? It does not make sense?
It makes sense.
Oh, it does make sense.
No, it does.
Oh, it does make sense. Okay, good. I thought someone said no, it didn't make sense.
Yeah.
Okay, so it does make sense. Okay, good. All right, good. Okay, so we're good. All right, so let's just test some values for X. Sharon, can we do that?
Yes.
All right, let's plug in a 1 for X. Okay? And see what the price of beef is after 1 week and what the price of chicken is after 1 week. Okay?
Okay.
All right. All right. So just plugging this into the equation here. All right. X is 1. What is that? We got 235 plus a quarter. Oh, you can plug in both. Go ahead.
Oh, do you want me to plug in both?
No, go ahead. Yeah. Oh, yeah, absolutely. Yeah, if you want to plug in first and solve later, that's fine. Okay, so after 1 week, what is the price of beef and what is the price of chicken?
Beef is $2.60.
Yeah. And just think in terms of money here. Like change. Yeah, 210. Great. Is that 210? I think it's.
Yeah. Wait. Check it.
I think it's. So we got to code. I think it's 215. But it doesn't matter. So they're not equal.
Oh yeah, 215. Sorry.
No, does it? But look, and here it doesn't matter because again, they're not equal. Right? The price of beef doesn't equal the price of chicken after a week, right? We can agree?
Yes.
Okay, great. So look, it's not answer choice A, right? Because when beef is 260, chicken isn't 260. So A's gone. Let's plug in a 2 for X. So 2 weeks after July 1st. We're gonna get it. Does it make sense what she's doing here, ladies?
Yes.
Yeah?
Yes.
Okay, good. Like, we are guaranteed to find the answer using this method. There's nothing to mess up here. If we can do the arithmetic. What does that give us, Sharon?
2.85 and
It's 175 plus 80 cents. Okay, we're getting closer, but they're not equal. And what answer choice can we eliminate, Sharon?
B.
B's gone. There we go. Okay, great. Let's plug in a 3. Let's do it. See if 3 does it.
I'm trying to find a space.
Yeah, just go right below. If you, by the way, you can move around on the whiteboard. You can like kind of pinch with your fingers if you want to. There's this little hand thing. There you go. All right. That works. Looking good. All right. I'm going to stop you real quick. We don't even need to worry about. We can eliminate answer choice C right now, right? Go ahead. And you can finish that if you like, but I think that would be $2.95 for chicken. Yeah, it's answer choice C is gone. D is looking really good, right? Can we agree on that, Sharon? D is looking pretty good.
Yeah.
Yeah. Okay. Let's plug in a 4. I'm thinking it's going to work. Let's confirm it. Looking good, Sharon. Looking great. So $2.35 plus $1, $3.35, $1.75 plus $1.60. If you want to use a calculator here, I'll let you. Blammo. Answer choice D. Any questions about that?
Yes.
Yes.
Whenever she did 4C
Uh-huh.
and she just did equals 310, you said you can eliminate it right now. Wait, why?
Yeah, just because the value of I just realized it wasn't very helpful, a very helpful point to make, but it's a minor point. But because the value of 310, we've already blown past 295, right? There's no way to make beef equal 295 unless
Okay.
like it's like X weeks is like some decimal or something like that, which it's not going to be. Does that make sense?
Okay.
Yeah.
Yes.
But I just realized it's probably more helpful if you just kind of continue with the operation and realize that 310 doesn't equal 295. So I never finished the point. Thank you so much for asking. I really appreciate it. Does that make sense, though?
Yes.
Okay, good. Other questions? How are you feeling about this test right now? Any better? And if the answer is no, that's okay. We're just getting started. How are you guys feeling right now?
I mean, pretty good.
Okay.
A little bit better.
Okay. This is doable. I'm telling you, this test is really not as complicated as you've probably been led to believe. It's really not. If you look at the questions the right way. It's logic and arithmetic is all it is. It took me 2 years of tutoring to realize that. I had literally like an enlightenment moment. I was like, wait a second, because I've had a student that was like, really bright student and really hardworking, and I was doing it the way pretty much every other tutor and tutoring program does it, where like, here's the operations, and we were just hammering operations again, and she just kept making mistake after just silly mistake after, and the same mistakes I would make as a student too. Like you just mix up a negative sign, with the algebra. You lose a variable somewhere along the way. Like lots of there's a million ways to mess up an algebraic problem. And then suddenly I was like, wait, what if we just look at the question this way? She's like, oh yeah, that makes a ton of sense. Great, that's C's the answer choice. And from then on, I've been tutoring this way with some very good success for my students.